So, welcome sa bagong-bagong episode ng ating lecture video series. So, for this episode, kukontinue lang natin yung discussion ng Module 4, Part 1, which is the differential amplifier. So, in the previous episodes, diniscuss natin doon yung DC analysis ng differential amplifier. Ang napag-usapan natin doon ay single supply differential amplifier and meron tayong range ng input common mode voltage. And kapag dual supply naman yung differential amplifier, nawawala po yung input common mode voltage na yun. And natutunan din natin kung paano mag-transform ng dual supply differential amplifier to single supply differential amplifier. So for this episode, ko-continue lang natin yun. Since tapos na tayo sa DC analysis, we can now proceed sa AC analysis. So what will be the voltage gain of a differential amplifier? Okay, so first of all, recall natin muna kung paano gumagana ang isang differential pair. So, if we will recall, the differential pair controls the current sharing between transistors, di ba? Kung sino yung merong mas mataas na voltage, siya yung merong mas mataas na current. So, this is the plot of collector current versus the input differential voltage. And the input differential voltage is defined as VI1 minus VI2. So, as we can observe, if VI1 is equal to VI2, ang kanyang current is 0.5 of the tail current. And if VI1 is equal to VI2, siya pala ay in the quiescent condition or wala po tayong AC signal. And kapag nag-apply tayo ng AC signal na VID, let's say VID is positive, ibig sabihin VI1 is greater than VI2. We can observe that the collector current 1 will increase and the collector current 2 will decrease. And if VID naman is negative, VI2 should be greater than VI1. So, ibig sabihin, the collector current in the transistor number 2 should increase. And the collector current in the transistor number 1 should decrease. So, kung ipa-plot po natin yan, if we have an input differential signal, VID, na ganyan, so, pwede po nating i-plot yung IC1 and IC2. So, if VID is positive, somewhere over here, greater than 0, IC1 will increase. Ano mangyayari kay IC2? IC2 will decrease. And if VID is negative or less than 0, IC1 will also decrease. Ang mangyayari kay IC2, it will increase. Okay, so ngayon nakita natin, a change in the input voltage will produce a change in the collector currents natin, both in transistor 1 and transistor 2. So, sir, sa amplifier, ang output natin doon is output voltage or the change in the output voltage. So, paano natin ko-convert yan into output voltage? So, dyan na po papasok yung ating load. Kung tatandaan natin, meron tayong load in the previous episode na resistive loads. Diba? We have 2 RLs connected doon sa collectors ng transistors natin. So, we have observed that a change in the differential input voltage will produce a change in IC1 and IC2. And we know the voltage across RL is IC times RL. If there's a changing current na IC, ibig sabihin the voltage across RL will also change. So, yun na po ang ating output voltage, di ba? So, ibig sabihin, a change in input voltage will produce a change in the collector current, and change in collector current will produce a change in the output voltage through the resistor RL po. Okay? So, to amplify, ang gusto natin, doon lang tayo sa area kung saan nagbabago ang ating currents. So, saan kaya ang region of operation ng isang amplifier dyan? Okay, so the region of operation, obviously, yung merong slope. Which is this one, di ba? Dahil nakita natin, if our input voltage is changing, tapos ang pag-change niya is within this region lang, nakita natin there is a change in current produced. However, if our input voltage is changing within this region, may nakikita ba tayong pagbabago ng current dito? Hindi, di ba? If our input voltage changes from 0.6 to 0.4, our IC2 is constant at this level, which is equal to ITIL, di ba? If we also change VID from negative 0.6 to negative 0.8, there's also no change in current observed, di ba? So, ibig sabihin, ayaw natin mag-operate in this region dahil wala siyang napaproduce na change in IC1. So, similar din po dun sa rightmost dahil constant lang po ang kanyang current dyan kahit nagbabago-bago ang ating VID. So, our region of operation for an amplifier should be bounded in this box po. So, ibig sabihin, meron lang tayong maximum na input voltage. So, yun na po yung tinatawag nating small signal. So, ngayon, nalalaman natin kung gaano ka-small ang small signal natin. So, bale, limited lang ang ating peak-to-peak input signal dito sa range na yan, di ba? Dahil kapag our peak-to-peak is andito, nakaka-produce tayo ng change in current and it will produce a change in voltage. So, if the input differential signal's amplitude exceeds this limit, mangyayari is magkakaroon tayo ng distortion. Okay? So, nagkakaroon ka ng clipping dito sa mga currents natin. In effect, nagkakaroon tayo ng clipping sa ating output voltage. So, ayaw natin yun, di ba? Okay, so ngayon alam na natin kung paano gumana ang differential amplifier. So, ngayon pwede nating i-derive yung mga output voltage gain niya. So, kung mapapansin natin, ang ating differential amplifier ay may symmetry, di ba? So, pag hinati natin yan dito, identical yung nasa left na circuit saka yung nasa right na circuit. So, siguro mas madaling mag-analyze kapag kukunin lang natin yung half circuit niyan para hindi masyadong komplikado. Pero, pagdating sa half circuit, kasi kukunin mo lang isang parte niyan, hindi mo magagamit yung differential input voltages and output voltages natin. Ang gagana lang po sa ating half circuits ay yung single-ended voltages, which is with respect to ground. So, ngayon, is there a way to convert differential voltages into single-ended voltages? So, by the way, in this example po, our input voltage is VID, which is differential, and our output voltage is VOD, which is also differential po. Okay, so is there a way to convert differential voltages into single-ended voltages? So, kung re-recall natin sa episode 1, meron po tayo na-discuss na ganyan, di ba? So, every time na makakakita tayo ng gantong system, kung saan may amplifier, tas ina-amplify nyo yung difference or the differential voltage between two nodes, pwede natin siyang i-represent as ganito. Okay? So, ibig sabihin, yung ating input differential voltage can be represented as this one. So, take note, this should be VID over 2. Okay? And papansin nyo yung VID over 2, yung sa VI1 siya yung positive, yung VI2 naman, negative yung VID over 2. How about naman yung differential output signal natin? So, ganun lang din pong gagawin natin. Pero instead of using voltage sources, dahil originally wala namang voltage sources dyan, bali quiescent points po ang ating hinahati. So, si VO1 can be represented as VOD over 2 plus VOCM. And VO2 naman is negative VOD over 2 plus VOCM. So, meron na po tayong single-ended signals po. As we can see over here. So, si VI1 is input differential voltage over 2 plus VICM. Si VI2 is negative input differential voltage over 2 plus VICM. Si VO1 naman is the output differential voltage over 2 plus VOCM. And si VO2 is the negative differential output voltage divided by 2 plus VOCM. So, yung mga VID and VOD natin, actually, yan po yung AC signal natin. And si VICM and VOCM, yan po ang biasing and quiescent voltages. So, si VICM is the biasing voltage as we have discussed in the previous episode. And yung VOCM is the quiescent point of this node. Or it is the voltage kapag wala tayong AC input signal. Okay, so ngayon pwede natin siyang i-transform into its AC equivalent circuit. So, ire-recall lang po natin natutunan natin sa module 1, di ba? So, first, VCC will be replaced by ground, di ba? And natanggalin lang po natin yung mga DC voltages natin. So, in this case, ano ba yung mga DC voltages natin dito? So, for VI1 and VI2, these are DC voltages. And for VO1 and VO2, these are the quiescent voltages. Or that is the voltage kapag wala tayong AC. Or that's the DC voltage. Diba? So, tatanggalin lang po natin yan. So, pag tinanggal natin yan, ang matitira is, ayan. So, VCC became ground, VO1 became positive VOD over 2, VO2 became negative VOD over 2, VI1 became VID over 2, and VI2 became negative VID over 2. So, take note pala, actually, hindi ko kasi na-edit. So, yung ITIL dito, this is a DC current source. And ginagawa natin for AC analysis, ginagawa nating open yung mga DC current sources. So, mawawala lang yan. Ang matitira dito is its output resistance po. So, after nyan, pwede na nating i-redraw yung BJT with its small signal equivalent model, which is the RE model, di ba? So, ganyan po ang mangyayari dyan. Okay? So again, wala po ulit tong ITIL na yan. So ngayon, paano natin siya hatiin into 2 circuits? So hindi pa naman siya hatiin into 2 circuits eh. Ginawa mo lang, kinonvert mo lang yung differential input voltage into single-ended voltage. Pero hindi naman siya nahati. Ayun o, meron pa rin siyang point of connection dyan. So, ganito yan. Okay? So, first, tignan natin kung dito pa rin ba talaga ang ating ground. Okay? So, we know, in the previous episode, na kapag nag-KCL tayo dito, makita natin that ITIL is equal to IE1 plus IE2. And ITIL po is constant. Hindi nagbabago yan. So, ibig sabihin, if there's an increase in IE1, there should be a decrease in IE2. Para masabi natin na tama itong KCL equation natin, di ba? And if there is a decrease in IE1, there should be an increase in IE2. So, ngayon, ano kaya yung phase relationship ng IE1 and IE2? Nag-increase si IE1, nag-decrease si IE2. So, ibig sabihin, IE1 is 180 degrees out of phase with IE2. So, take note, yung mga small signal current natin is just the change, okay? So, ito po yan. Yung change in IE1 saka yung change ng IE2. Kaya positive si IE1, negative si IE2 dito. Okay? So, kapag inad natin yung small signal IE1 and IE2, lalabas dyan ay the small signal tail current will be 0. Diba? If the small signal tail current is 0, so yun po actually yung nagpo-flow sa ating R-out dahil wala tayong ITIL dyan kapag AC, diba? Ibig sabihin nun that the voltage across R-out is 0. Kapag 0 po yung voltage across R-out, ibig sabihin the voltage at this node is actually 0 volt. Since 0 volts po yan, ibig sabihin yan ay ground, diba? So, nangyayari is this emitter terminals po became AC ground. Okay? So, papalitan lang natin yung R-out ng ground. So, ngayon, pwede na natin siya mahati into 2 half circuits. So, tatanggalin ko yan, tapos bibigyan ko sila ng tig-isang ground. So, mapapansin natin, each half circuit is similar to a common emitter AC circuit or the fixed bias po dahil wala tayong emitter resistance dito. So, therefore, we can analyze each half circuit. So, for half circuit 1, kung natatandaan natin yung formula ng voltage gain ng common emitter, siya ay negative RO in parallel with RC over RE. In this case, RC is RL po. So therefore, VO1 or the single-ended voltage at this node over the single-ended voltage at this node will be this one. And VO2 naman is the same po. So VO2 over VI2 is negative RO in parallel with RL over RE. Pero alam natin, nung kinonvert natin yung differential signal into single-ended signal, ganito po yung lumabas, di ba? We know that VO1 is equal to VOD over 2, and VO2 is equal to negative VOD over 2. VI1 is equal to VID over 2, and VI2 is equal to negative VID over 2. So kapag plug-in natin yung mga VO1 and VI1 na yan sa ating mga equations for half circuits, ang lalabas dyan is VOD over VID is equal to negative RO in parallel with RL over RE. So, please take note, our output voltage here is differential and our input voltage is differential as well. So, this is Sir G from the future. So, ika-clarify ko lang po ito . If we say differential voltage gain, ang ratio po niya is always the output voltage, either differential signal siya or single-ended signal, over the differential input voltage. As long as the input voltage po is differential, we will consider the ratio of the output to the input as a differential voltage gain po. So, yun lang po. Bye-bye! So, ito na po yung derivation ng ating differential voltage gain sa differential amplifier. So, hanggang dito lang muna dito sa episode na yan. For the next episode, consider natin what if there is a common mode noise. So, ano kaya mangyayari? Di-discuss natin yan in the next one. So, I will see you in the next episode. Bye!